example, for the aerodynamic test, we want to know the aerodynamic flow, and also we can measure the total pressure. In that, we have static pressure and dynamic pressure. Okay. For example, there is wind tunnel investigations aiming to reduce the aerodynamic drag of the bus. Okay. Left figure shows the wind tunnel. Okay, wind tunnel. And then right figure shows the experiment. Experiment during the experiment view during the experiment. You can see here the air flow goes to the body of the bus. Tengoklah dia punya pattern, flow pattern. Di sini. And then normally we put the bus model. We cannot put the actual model. We can only scale down the bus model to the 2 feet. 2 feet inside the test section. For example, this area is the test section of the wind tunnel. So benda ni ada dalam ni. Itu ada dalam ni. Okay, and then the wind tunnel specification is ini. Okay, maximum velocity is 50 meter per second, and blah blah blah. And bus model we scale down to 1/5. Scale down to 5, which has the rotating wheels, and then dia kata ada detail underbody, and then interchangeable parts. Interchangeable parts. Okay, and then this is the results when the researcher changed the bus body geometry. Okay, there are several changes that has been made, and then in summary, saya tak pergi detail lah. In summary, they can reduce the drag coefficient from 0.57 to 0.39, almost 30%. Almost 30%. Meaning that can reduce to 20% of fuel consumption at 100 km per hour speed. Okay. Okay, ini sama. Okay, this is the example of the wind tunnel. We can have actual car, tapi dia punya wind tunnel besar lah. Must be large wind tunnel. We can have F1 punya model inside. Okay. Membeli F1 punya maker, dia akan masukkan actual punya model lah. Actual model. Maksudnya testing area tu mesti besar. We can also have motorcycle. In Malaysia, if I'm not mistaken, we have a wind tunnel, tapi tak boleh masuk kereta sebiji lah. Dia boleh masuk half car. Motorcycle boleh masuk. Kita ada di UTMJB, dan tak salah saya ada di UM juga. Ada di UM. Sebab kos untuk build the wind tunnel ni very costly. Berapa juta, puluh juta lah. 10 juta. Kalau actually beratus-ratus juta RM. Okay, on top of kita buat experimental work, kita pun boleh buat simulation work. Simulation. We study, for example, here we study the mud deposition on rear wall of the buses. Boleh buat guna numerical simulation. Normally we using the ANSYS software. ANSYS software. Nama software tu lah. And also we can use the HyperWorks. HyperWorks. Okay, this example of the simulation of mud deposition on real world of buses. Okay, tengok sini. Pass flow the wheel. Okay, wheel. Okay, so kita habis untuk road loads for aerodynamics. Next, we go to the next road load, which is rolling resistance. Okay, at low speeds on hard pavement, the rolling resistance is the primary motion resistance force. And then the mechanism of rolling resistance we can create as seven factors. Seven factors. First is energy loss due to the deflection of the tire sidewall near the contact area. Secondly, energy loss due to deflection of the tread elements. Three, scrubbing in the contact patch between the tire and road. Four, tire slip in the longitudinal and lateral directions. Fifth, deflection of the road surface. Sixth, air drag on the inside and outside of the tire. And then energy loss because of the bumps. Because of the bumps. Okay, and then this is the rolling resistance punya equation. Okay, summation of front tire rolling resistance and rear wheel rolling resistance equal to FR. FR is the coefficient of rolling resistance times vehicle weight. Okay, vehicle weight. So go back to our first chapter. Okay, where is the rolling resistance? Okay, for example, the vehicle climbing the road. So the rolling resistance at front tire ini. Okay, direction against the vehicle travel. So rolling resistance at rear tire ini. Okay, and then there are factors that affect the rolling resistance, such as tire temperature, tire inflation in terms of pressure and load, tire velocity, tire material and design, and tire slip. Okay, we will look into each of these factors. Just tengok overview je lah. So, tire temperature. So, when the temperature tire must be in correct temperature because it will affect the rolling resistance. Okay, for example, this is the temperature rise of the inside the tire. Okay, the suitable is when the tire is at the around 40 Fahrenheit. 40 Fahrenheit. Okay, kalau kita tengok, kalau you notice pada F1 kan, kalau siapa yang tengok F1, tire temperature tu mesti in quite value, exact value. Okay, tire datang tak boleh sejuk. Oh ni, siapa minta tolong ni? Ni. Sasis dan. Ni kan? Okay. So kalau kita tadi F1 car, tire tu mesti to have optimal rolling resistance between tire and road. Tire temperature must be in a perfect condition. So kalau tire tu sejuk, so rolling dia tak bagus lah. Sejuk tak bagus. So tire kena have the correct temperature range lah. Kalau hot tu lagi dah bagus kan. Dia mesti ada range dia lah. Okay, that one is for tire temperature. And then next one is tire inflation pressure or load. Okay? So load to based on the material of the road. Okay? If concrete or medium hard soil or sand, so it has different rolling resistance and also inflation pressure. Next, we go to the tire velocity. Okay, tire velocity also contribute to the rolling resistance. Okay, it also depends on the, okay, for example, also depends on the type of the tire. Okay, contohnya kita ada bias and radial. Okay. And also bias belted punya type. So if you can see here, the type of the tire, okay, will remain, the rolling resistance coefficient will remain from 0 to 60, around 60 mph, miles per hour. Okay, after 60 miles per hour, it will drastically increase. Okay, and then it also depends, the rolling resistance also depends on the tire materials and design. Okay, for example, there are two types of tire, A, B, C, which has different material and different design. Different material. Okay, kita tengok dia punya rolling resistance coefficient also has different values. Okay. So biasanya untuk tire A ni lagi kurang rolling resistance lagi bagus kan. Okay, lagi kurang lagi bagus. Okay. So maksudnya dia production punya type lah, or material dan sebagainya. Okay, and then the next case is tire slip. Okay, tire slip. Okay, x-axis is the slip angle. The slip angle. And then this is the speed of the tire. Normally tak banyak beza, from 30 mph to 60 mph. Okay, and then we can see here the rolling resistance coefficient will increase as the slip angle increase. Okay, as the slip angle increase. Okay, this is the rolling resistance punya typical coefficient. It depends on the vehicle type, whether the vehicle is passenger vehicle or heavy truck or tractor, and then it also depends on the road punya material. If concrete and passenger car, the rolling resistance is 0.015. Okay, if the passenger car and running on the sand, so the rolling resistance is quite high, goes to 0.3. Okay, 0.3. And then on top of that, on top of the typical coefficient for rolling resistance, okay, This equation is represents the rolling resistance, Fr, okay, equal to Rx. Rx is the rolling resistance force divided by weight of the wheel, okay, equal to C. C times W over D and square root HT over W. Okay, detail kat sini lah, detail punya parameter. Okay, and then this is the rolling resistance force. Okay, yang tadi X tadi ini Rx ni sebenarnya Rx is equal to Fr ni Rx sama je Rx semua simbol dia beza tapi benda je sama okay, they are different rolling resistance force depend on the tire types and vehicle. Okay, number one, for example, for the radial ply passenger car tire, so if you want to determine the rolling resistance force, you must using this equation. Okay. V is the wheel speed. Okay, wheel speed. For vehicle speed, normally we assume similar, we assume sama. Okay, and then this equation number 2 is for bias ply passenger car tire. Okay. Number 3 is for radial ply truck. Number 4 is bias ply truck tire. So the equation for rolling resistance force is different. Is different. We must take care or we must consider the tire type and also the vehicle type. Okay, and then if we total all the road loads, we have aerodynamic force, we have rolling resistance, and we have road slope. So the total road loads, the equation we can express as this equation. RRL total road load equal to rolling resistance. Saya ambil yang term yang simple dah. FR, rolling coefficient times weight ke weight plus aerodynamics force. Equation ni plus if the vehicle is climb the road, kita ada grade force. W sin theta. Okay, until now boleh?
Boleh sir.
Okay, boleh Okay, right. So this is your quiz. This is your quiz. So the quiz mentioned that a passenger car has a frontal area of 2.32 meters square. Maksudnya frontal area. Ini saya coting nampak? Ya. Yang saya coting nampak tak? Oh, saya coting ni.
Nampak.
Nampak? Okay. Right. Okay, the frontal area of the vehicle is 2.32 meters square, meaning that A lah. Okay, that coefficient CD 0.45 and travelling speed, okay, 88.5 km per hour. Okay, soalan dia, calculate the aerodynamic drag. If the vehicle is drive 40 km per hour headwind, ada headwind 40 km per hour and tailwind also the same speed 40 km per hour, and then assume the density of the air is 1.23 kilogram meter cube per meter cube. So equation ini nak guna yang tadi lah ini, okay, aerodynamic force. So calculate the drag dia, aerodynamic drag dA tadi, okay, dA tadi equal to half rho B equals to 2 CD ada tak? A, okay, times A. Okay, boleh. So semua boleh masukkan dalam parameter ni, tapi you kena be careful. Kita ada dua condition. So ada something you kena buat kat sini. Satu ialah 40 km headwind and 40 km tailwind. So apa nak buat, kan? Kita ada sini 40 km per hour headwind and also 40 km per hour tailwind. So you kena cari sikit, make your homework sikit, sama ada speed ni you kena tambah atau tolak dengan vehicle speed. So kena combine ni, kena combine ni and then masuk dalam V sini. Sama ada mana vehicle speed plus headwind ke plus tailwind ke, atau vehicle speed minus headwind ataupun tailwind. Okay, make some homework. Saya tak nak bagi semua. So, and then plug back the velocity here and then you can solve the aerodynamic drag.